Today's episode is sponsored by Datadog, a modern full-stack monitoring platform for cloud infrastructure, applications, and logs metrics, all in one place. From their recent report on serverless adoption and trends, Datadog found half their customer base using EC2s have now adopted AWS Lambda. They've examined real-world serverless usage by thousands of companies running on millions of distinct serverless functions, and they found that half of the Lambda invocations run for less than 800 milliseconds. You can easily monitor all your serverless functions in one place and generate serverless metrics straight from Datadog. Check it out yourself by signing up for a free 14-day trial and get a free t-shirt. Visit datadog.com/HanselMinutesShow to get started. That's datadog.com/HanselMinutesShow to get started. Hi, this is Scott Hanselman. This is another episode of Hansel Minutes. Today I'm talking with Megha Vujjini. She's a data scientist with Segeza. How are you?
Hi, Scott. I'm good. How are you?
I am very well. So you work in data science at a company called Segeza. What does Segeza even mean? That's an interesting name.
It means wisdom. And because we come from a consulting firm, we are using all of this to provide solutions. And I think it's very apt considering the space we are in.
Yeah, it is. And as a space as a data scientist, but you didn't start out in data science. You were interested in telecommunications and engineering.
Yes, I started out in electronics and telecommunications. My major was electronics. But again, all of the space, I started doing a lot of robotics. I think that's where I got hooked to data and, how you are using data to make sure something works. It's just ones and zeros when you look at it, but those ones and zeros are moving something. So I think that's how I got into this field, and then a lot of analysis. Oh, my robot has to go straight, but it is not going straight. Let me look at the data. And then I think that's how I slowly moved into this field.
Yeah, when I started out with like basic databases in the early 90s, I just thought about it in terms of tables. But then robots and IoT and like streaming data, clickstream, like data over time is so fascinating. Huge amounts of data that can be presented. And then if you have a fleet of robots, like it's like one robot, all of its things it can do, all of its axes, then you times that by N number of robots or cars or thermostats or whatever. And suddenly a very simple problem with a couple of tables suddenly became a massive data store. And there's so many questions you can ask it.
Yes, I think we call it like increasing dimensions in your data set. Okay, you were only looking at, like you said, access, but now you have like 5 different degrees of freedom. The robot is moving in so many directions. And yeah, I think once it goes beyond your neat structured tables, things get a little bit complicated. Again, this is not data science. This is just data. We are not doing any science here, but I think it was a good place for me to start.
Well, so data, yeah, but data science, like you said, it does start with data, and then you add in n number of sources, and x number of you change the frequency or the sampling rate, and you have a huge amount of data that's just like you said, ones and zeros. The data science starts where? When I guess a business person has a question?
Not necessarily business person. Even when you are looking at the data, and if you have a question, it could start from you also, because one of the things that's important for us is to read those ones and zeros and put it in some context. Because again, zeros and ones don't make sense, but in a context, they tell a story. What is it saying? And is it a problem? Should I solve it? Can some other data be brought into this context to solve this problem? So it doesn't necessarily have to come from the business. I mean, it always usually does, but it does start from ourselves also.
Right. These questions come from anywhere.
Yeah.
Right. And then the idea of bringing data from somewhere else, again, when I started out, I thought about a table join. And for me, data was limited to the database I was working in. But I know that data scientists draw correlations and effectively table joins between databases by saying, well, this data correlates to that, or I could bring a map or some map tiles or whatever, and now I can see my robot on a map and pull from multiple sources to ask and answer questions.
Yes. I don't know how many of us actually do that much of a complicated, high level stuff. Maybe, you can do data science even on just one database and tables and just joins. You don't
Mm-hmm.
always have to, you know, use live clickstream data or Twitter data with
Mm-hmm.
addition to your database to come up with useful insights. You
Hmm.
can use what you have, but again, there has to be substantial data. I'm not saying, oh, I have like 2 weeks worth of data, please tell me what's going to happen 2 years down the line. That's ambitious, but all I'm saying is it's not always necessary that more data means a good thing.
Okay, well, that actually brings me to a really good question then. When does a database person or someone who is select star from this and that with a modest database, when do they become a data scientist? When does database administrator or data wrangler graduate if I'm going to get into this field? And when does it become science?
So again, are you solving any problems? Are you
Mm-hmm.
doing your select star for a purpose of something? Okay, let's say you're doing a select star, all my employees in the company. Why? Do you want to see the probability of someone leaving? Do you just want to be more prepared? Again, like let's say because I'm in consulting, there is this concept of a bench where,
Mm-hmm.
even though you're just waiting for the projects to roll in and you have a resource ready to go. So if I am a database administrator, I will do, okay, select star my projects and my employees. But if I want to be a data scientist, what I'm going to do, what's coming in, how many resources will I have at that point of time, and how do I make the data tell me how many resources I need at any point of time. You know what I'm trying to go with this? Does that make
Sure.
sense?
I, what I
Yeah.
what I'm hearing is there's a question, very often a predictive question.
Mm-hmm.
There's some data that represents some historical context, but some business context that I may or may not understand. And like you said, it's like I can answer basic questions like give me all of the people and their salaries and sort, but I could ask more complicated questions like is this division losing people? Why are they leaving? Why do people enter this division and then leave? Like I can answer all kinds of questions over time that are going to predict the future, like you said.
Right. Do you see a trend somewhere? Are all the people leaving from a particular age group? Or are they all leaving after, let's say there is this amazing project, but as soon as you're placed there, everyone just leaves? Is there something going on? Finding a trend or a story within your database. Once you
Mm-hmm.
start doing that, once you start analyzing your data and giving it a context, I think you can say, yeah, you're touching the basics of data science.
So when does data science start to get into machine learning? Because I know that you do some work in AI as well. Like if I were going to make a model
Hmm.
and then make a prediction, I make a predictive model. Am I an AI engineer? Am I a machine learning engineer? Or am I still in the space of data science? Or are they the same thing?
They're all the same thing. I mean, they're all in the same space,
Mm-hmm.
but I think it's off late that few companies are breaking up how they define data science
Hmm.
because it's such a vast field,
Mm-hmm.
and what you do is all specific to the problems you are trying to solve or specific to the company you're working for. So now we have like machine learning engineers or algorithms research. These guys are only working towards how do we make our machine learning algorithms better or faster or more accurate. But AI engineers, they're trying to do more deep learning stuff. But
Mm-hmm.
again, all of this is data science. I mean, yeah, you are using your data and science behind it to come up with solutions. How are you doing that is, you can just break it. Are you doing cutting edge research? Are you just applying predictive analytics or statistics? It all comes down to what you're trying to do. I think.
Here's the part that I find confusing, though, is we are creating these models, these AIs, these systems of data science that are using historical data, right?
Mhm.
Because by definition, all data is from the past. It is very likely imperfect data. And then it is going to then express, or we're going to hope it expresses, some theoretical predictive future. It seems so ridiculous that we're building models assuming that past results can predict future ones. And that's where the jump, I think, is so challenging.
I think this is where BI comes into place. I mean, before AI, there was always business intelligence, and business intelligence mostly is to make sure that there is data integrity, and that would be a good starting step. Okay, I know you say you have data, but is that data right? That's where BI comes in, and probably using the correct data. You're just saying, again, we are not stating that, oh, this happened in the past, it will happen in the future. All we are saying is there is a high probability of this happening in the future. We don't talk in these terms to the business, but as statisticians, we are always like, okay, there is an error percentage, but we are leaning towards the possibility that this is
I see.
happening or going to happen. And if it's more than like 50, we are happy with it. 50 is, I mean, yeah, it's a true or false at this point of
Really? So
time.
you're really just trying to beat a coin flip.
Yes. No, yeah. I mean, let's say I flip coin 100 times. Can you say what am I going to get in the next 5 times? No. So it's pretty much, but yeah, I know it's not that simple, but no, we cannot say for sure that this will happen in the future, but we can say, okay, I'm 90% sure that this will happen in the future.
So when you go and you want to test these models, you've got some data, you're thinking about testing some prediction about it, you're making this predictive analysis model.
Hmm.
I understand that there's a training data set, there's a test data set, maybe there's a validation data set.
Yeah.
What is the relationship between the training data set, the thing that you're training it on? Do you train it on all of your data or do you pick and choose? How do you make the decision about what you train on? Because I understand that picking the wrong training data set, like garbage in, garbage out, right?
Right. So don't pick. Make it as random as possible because if you
Mm.
want your model to work, again, the whole reason of training and testing is because once you are going to deploy it, the data which the model is going to ingest, you don't
Mhm.
know how it's going to be. So, why do you want to train it on a specific kind of data? And then once you deploy it, it doesn't work because the data that you are getting in real time is completely different. So, you're essentially training it. You're training it to be as robust as possible, and if you pick it, you're probably going to get like, oh, it's 98% accurate, which means you're probably overfitting the data. So make it as random as possible. Once you train it and you say, okay, it works, just test it out. Test it out on a data which was not part of the training set to see, okay, if I ever deploy it in a real time situation, how is it going to be? And probably that's the only relationship between training and testing, both as random as possible, but 80%, 20% is what we most usually do.
hmm Now, you used a word there that I don't think everyone caught. You said overfitting. Maybe you've overfitted that. Maybe you could talk about what an overfitted statistical model is.
It would say, let's go back to the coin toss. I toss my coins 100 times. I got 98 times heads and 2 times tails, and I'm training a model on this. And I'll just say my model, okay, what is the probability that m- just tell me what's going to happen in the next 5 tries. Based on this data, it's going to tell me it's probably going to be heads because 98 was out of 100 is a high thing. So this is
hmm
what overfitting is. Your data is so skewed and your model is so accurate and perfect, it just thinks, oh, this is how the data always is.
Interesting. Okay, so you're saying that you have pulled out some variation, some noise,
Hmm.
and then now you think that noise represents reality. Like I happen to pick 5 heads in a row. That's my sample. I go and fit to that. And now what should be a random 50-50 is now 100% because I've completely overfitted based on a piece of noise that now potentially represents the model's structure. I've lied to myself.
Exactly. Yes, that essentially is what overfitting is.
How do you know it happens though? Like if you're working with data like coins, I can see that you can look at it and think it through. But if you're working on something big and complicated like voting, or something like that,
Yeah.
how do you know that you're right? Because that's the thing. You're asking a question to which you don't necessarily know the answer. Well, let me back up. There are data science problems for which I don't know the answer, so I can make a model and I still don't know if I got it right. And then there's stuff where I can actually say I've trained this and now I know that I got it right because I have a validation piece of data, a data set that's validatable.
Well, it's a funny story. If the answers are too good to be true, it means we've probably overfit them.
Mm.
It's an unfortunate part of the job, but no. Generally, in reality, we are not supposed to get such perfect models or such perfect fits. If you say, "Oh my God, your model is working with 98% accuracy," we know we overfit it. Like you ask anyone, we just know it. So we go back, we change our training sets or testing sets, or we just create random data sets and see, okay, what's going on, and then we try to change the variables, tune it, and make sure what comes up again. Yeah,
Interesting.
that's all it is. It's a lot of trial and error because when you're working with such huge data sets, you can't go line by line or table by table and figure out what's going on.
Mm-hmm. I heard someone say once that overfitting is when the model is starting to memorize the data as opposed to learning the data.
Yeah, that's a good way to put it. Right. Instead of seeing the trends, it's just like this is what the data is. So this is what the data will look like. Not that, oh, after every 4 or 5 tries, I'm getting aheads. So every 4 or 5 tries, I will get ahead. Yeah, no, that's a good analogy.
All right, that makes me happy. I'd like to welcome our new sponsor, Couchbase. Couchbase is an open source NoSQL document and key value store database. Requires no external cache, supports SQL and analytical queries for JSON data. Couchbase supports technologies like Kubernetes, Java, .NET, JavaScript, Go, and Python. Download it, give it a try at couchbase.com/HanselMinutes. That's couchbase.com/HanselMinutes. And I'll remind you that when you support our sponsors, you support this show. How often do you find yourself doing these kind of cool, heady things that we've been talking about versus just cleaning data? Like, how much are you a data janitor versus a scientist?
80% of my job is cleaning the data.
Really?
Yes. Modeling hardly takes, I wouldn't say hardly, but modeling takes up much less time than I wish.
Mm-hmm.
A lot of it is data cleaning or more so data gathering. The
Really?
number of times I had to just like, where is the data? Where is the data I need? Not just, you really need to start with defining a problem. Okay, this is the problem. What is causing this problem? Do we have data relevant to that? Just because, let's pick an example for voting. You want to see how the voting outcome is going to be. How is weather going to affect that? I have so much data and it's all weather data. Is that going to affect my voting? Probably not. So, data gathering is step one, and then comes the data cleaning, making sure that, okay, I have this vision or this path, which or these algorithms that I'm going to use. How do I wrangle the data? So, unfortunately, 80% of my job is just being a data janitor.
Mm-hmm. So you are filtering out things that you don't
Mhm.
want. You're removing things, you're dropping things. I presume that you're removing outliers of a certain kind.
Outliers of a certain kind are, cutting down dimensions because if two things probably say the same thing to me, I have one column which says is hot, the other column which says is not cold, they probably both mean the same thing.
Mm-hmm.
So just cutting those things out. Yes, starts with filtering, then making sure that I don't have, missing values or uh, just random data which is not part of the trend. And then again, next step, what am I trying to do? Do I have enough?
In the real world kind of work that you're doing, I'm curious about this because I learned it in school, but I've never dealt with it in the real world. Is how often is the normal distribution, like the bell curve that we always talk about, a real thing, or is that just a thing we learned in school? Is that true?
We, I haven't come across it yet. I'll be honest.
So it's statistics aren't as clean as we think they might be when you apply
Yeah,
variance and a lot of stuff.
you just go with the assumption that it is a normal distribution, but if you actually put it, I think I did try. I had the same question as you did.
Mm,
Okay, is this following a normal distribution? Am I going to get that nice inverted U graph? No.
hmm
But all these statistical tests are built on the assumption that your data is normal distribution,
hmm
and you just go ahead with faith. They're not perfectly you, but yes, you see outliers and you see a lot of the data falling into a group. In a way, yes, normal distribution, but not perfectly normal.
hmm As I'm teaching my children math and basic statistics, they're only 12 and 14. One of the
Hmm.
things that we've been using without swearing, but I'll use this term, do they know how to detect BS? Like, does it smell bad? When you have a math problem, you should have a good sense of smell, you know? And I understand that when you're a data scientist, you look at a data set, you look at the top 20 rows, the bottom 20 rows, and pick some in the middle, and you say, is this BS? Does this smell right? Does this data make sense? And make whether or not it makes sense depends on the kind of question you're trying to ask, right? Is it names? Is it addresses? Is it numeric? Is it lat lon? You don't know given a giant data set whether this is nonsense or not.
You don't. You have to get your hands dirty, spend some time with it before you just come to the conclusion that it is BS.
Mm,
Unless it's a very small data set. But again, in real world, we don't deal with small data sets. With the whole advent of big data and cloud, and the data sets have like grown tremendously.
hmm
And yeah, you need to spend some time with it, run basic exploratory analysis to come up with your own conclusions.
What data science tools are you using? If I'm listening to this and I'm thinking maybe this is a fun job. There's thousands of tools. There's even hundreds and just for visualization. But what are your toolbox of main tools for being a data scientist?
I use R and Python. They
hmm
are both really good and powerful for data analysis, the starting analysis. And then obviously you should have, if not absolutely well versed, you should know how to engineer your own data, if I have to say.
Okay.
So SQL, or working with cloud warehouses, you should have all these tools. So I work with Snowflake, I work with SQL, I work with Python and R. And for visualization tools, you can visualize using Python and R, but if you want tools, Power BI and Tableau, these are pretty good. I think these are the standard. So I've had experience with these.
hmm And when you're working with, you say Python and R, is that something where you spend time in a Jupyter notebook, or where are you doing this work?
Yes. I For R, I use R Studio. I think that's the best IDE for it.
hmm
For Python, I use Jupyter Notebooks. I also, because I said I do work extensively with Snowflake also, Snowflake has its new partners called Zeppel. Everything is built on like a Python Jupyter Notebook interface, but I've been trying out new tools. I think once you can master Jupyter Notebooks, everything else should be sort of similar.
hmm And for people who don't know what Snowflake is, it's a cloud-based data warehouse. So this idea of
Yes.
a data warehouse is like more than a database. Like it's like you think that this store is big, go to Costco. That's a warehouse.
Yes, it is like that. Instead of one database, you have more than one database, or
Yes,
maybe one huge database.
exactly.
However, it makes easier.
It's a whole world of data that you could potentially pull from. And you're dealing with data mostly in the cloud. Like when I was doing work 20, 30 years ago, I would be doing it on a desktop or a laptop, and I'd be dealing with only some gigabytes. What's the biggest thing you've ever pushed around? What's the biggest amount of data you've messed with?
I don't know in terms of memory, but I could say in terms of number of rows, just one of the tables was like a 40 million row. Again, that's small comparatively to the data sets that people are using around. But yeah, 40 million rows.
So 40 million rows is small, is a modest data set.
Yeah, I think once you've worked with that much data, everything else seems small. But no, I speak to people. They are working in terabytes of data and trying to understand. And that's amazing work. Like,
Mhm.
where do you start? So,
So you said that people should start with Jupyter Notebook. So if you find data interesting, you can sit down and make a Jupyter Notebook at any of the cloud vendors. Jupyter Notebooks works if you're using Visual Studio Code. You can go and create your own environment locally, get Python all set up, and start learning Jupyter Notebooks. Do you think that's a good place to begin your data science journey?
it is. I know Kaggle is amazing. When I was in school, I would always go on to Kaggle. They have so many competitions. They already have notebooks for someone new to come and take a look and see, okay, this is how everyone else is doing or breaking down that data. And they always have new problems, and it's so well sought out. I know there are a lot of data sets that were put on Kaggle by IBM or Google because they were trying to see how everyone else is having a perspective towards this. That would be the best place to start because you also get your hands on data.
Mm-hmm.
There are so many open data sets, but I think Kaggle is a really good place to start.
Uh-huh.
You can choose your language. You can choose to do it in Python or R or whatever other languages you are familiar with and take it from there.
Okay. And Kaggle or Kaggle.com is KAGGLE.com. I really like their homepage because it says start with more than a blinking cursor. You don't teach someone how to code with hello world necessarily. You say, here's 20,000 public data sets. Go play and ask questions. It's a great way to get started. Rather than learning in the shallow end of the pool, you just throw them into the deep end and see them swim.
Yes, that's true. And as a data scientist, you always need to have or need to put a context to your data, and this pushes you to do that.
Mm-hmm. Well, I really appreciate you chatting with me today.
This was great, Scott. Thank you for the time.
Yeah, appreciate the opportunity. We've been chatting with Megha Vujjini. She's a data scientist with Segeza, and we're learning all about pathways to data science. This has been another episode of Hansel Minutes, and we'll see you again next week.